to use L'Hopital's rule. All right, so let's say I'll wait till you're done writing before we use an example.
That last one, that's infinity times infinity, and then what's the fourth one?
Oh, infinity minus infinity. Yeah.
So infinity plus infinity would just be infinity at that point, right?
Well, a really big number plus a really big number is just going to be a really big number. But because infinity, when you're subtracting them, with that one, you can't really manipulate it to being L'Hopital's rule. Right. So you just kind of look at that as just a really big number. But because you're subtracting, you don't know which one's bigger than which.
Right.
So you don't know if you're subtracting the first one could be bigger than the second one, or the second one could be bigger than the first one.
It's like when you take 500 plus 300, 800. But when you take 500 minus 300, it's different from
Exactly.
300 minus 500.
Exactly. Yeah. But when you're adding them, it's just a big number all around.
And what's the difference between infinity times infinity? Because that's the same either way.
Oh, it's just to use L'Hopital's rule.
So those are all indeterminate.
Well, yeah, they're not in indeterminate form yet, but they can be manipulated to be in indeterminate form. Because really, infinity times infinity is just infinity plus infinity plus infinity plus infinity, an infinite number of times. So it's kind of the same thing.
So L'Hopital's rule can't be used as the derivative of g of x, which is our denominator, which equals 0, or if any one of those instances were to happen.
Yeah.
Besides when you convert them afterwards.
Exactly.
Okay.
Yeah, but you can convert them.
Right.
All right, so let's say, for example, well, if we want to find the limit as x approaches 0 from the right of 2 over tangent of x minus 7 over x squared. Nope, might as well put parentheses around both of those.
Love your trig, don't you? Love your trig.
Yeah, trig doesn't really go anywhere. So the limit as x approaches 0 from the right of 2 over tangent of x minus 7 over x squared. Okay, so we know, just to kind of give a visual, let's say we know that this is our tangent of x, our graph of tangent of x. Okay, so we know as you're approaching 0, closer and closer, that number is getting smaller and smaller. So if you divide 2 by 0.1, you'll get 20, I believe. Then if you divide it by 0.01, you get 200. 0.001, you get 2,000. So as that number gets smaller and smaller in the denominator, that limit gets bigger and bigger and bigger. So actually this will end up equaling infinity. And as this denominator gets bigger, but not bigger and bigger and bigger, as it gets closer and closer to 0, yep, it becomes infinity as well. Because as that number gets smaller and smaller and smaller, you're now dividing 7 by a smaller number, an even smaller number, an even smaller number. So that becomes infinity. Okay. Which is not indeterminate, so you can't use L'Hopital's rule. So no L'Hopital's rule. No L'Hopital's rule for you. I was wondering who would get that reference. Something for you. All right, so that means if we have the limit as x approaches 0 from the right and give that a little bit of space. So we have 2 over tangent of x minus 7 over x squared. We multiply this one by x squared over x squared, and this one by tangent of x over tangent of x. Then we'd end up with the limit as x approaches 0 from the right of 2x squared minus 7 tangent of x over x squared tangent of x. Okay. So 0, if you plug in 0, we end up with 0 in our denominator. And here we end up with 0 minus tangent of 0. So if you remember, tangent of 0 is just sine of 0 over cosine of 0, which is 0 over 1, which is just 0. So you have 0 minus 0, which is 0. So we finally have our indeterminate form.
Can you find the derivative of that?
Yep.
Well, we have to get the second derivative, so.
With that one, nope, actually just the first. Okay, so we can use L'Hopital's rule. So you have the limit as x approaches 0 from the right. Derivative here, you have 4x, well, might as well write derivative instead of skipping steps. So you have the derivative of 2x squared minus 7 tangent x over the derivative of x squared tangent x. Okay, which gives us limit as x approaches 0 from the right, 4x minus 7, derivative of tangent is secant squared, divided by, move this right out make that a little clearer. Using the product rule for this one, because we have to find the derivative of the entire thing. So we have x squared secant squared of x plus 2x tangent x. Uh-oh, move that up some. Okay, so if we apply the limit to both of those, 4x minus 7 secant squared of x divided by the limit as x approaches 0 from the right of x squared secant squared of x plus 2x tangent of x. Here we actually get a limit that's approaching 0. Okay, because as it gets closer and closer to 0, this just gets smaller and smaller and smaller and smaller and smaller. But this one, as you plug it in, you get 0. And here, as secant squared, remember that's just 1 over cosine. So you get 1 over cosine as it gets closer and closer to 0. This just gets closer and closer to 1. So you have negative 7 over the limit, which is really equal to 0. So as this number gets smaller and smaller and smaller and smaller and smaller, this number just gets closer and closer and closer and closer to negative infinity. So you end up with negative infinity. All right, so any questions on that one?
So the bottom one, you said the limit as opposed to
Mm-hmm.
the right.
Mm-hmm.
So would you just plug in 0?
Well, you can't plug in 0. because it will make it undefined.
Right.
So you just have the limit as it's getting closer and closer to 0 is the limit is 0, which means that.
No, I understand.
Oh, okay.
What I'm saying is to get 0,
Mhm.
to get the limit of 0 as it approaches the right side.
Yes.
Would you plug in 0, or would you plug in, say, 1, because it's positive coming from the right? That's what I'm asking.
1. Well, you wouldn't plug in 1 because it can be it can be 0.1, 0.01, 0.0001. That's why I put the limit down there to show, because you can't just put over 0, because then you just kind of wipe out the whole thing.
Right.
So if you put the limit is equal to 0, that just means that as it's getting closer.
Wait, can you explain how you would get that again?
Which one?
How you got the limit of the top one and the bottom one, and how you got -7 over 0 overall?
Oh, no problem. Okay, so let's say if you have the limit of 4x is just 0 if you plug it in. If you plug in 0. Okay, but secant squared is just 1 over cosine squared.
You plug in 0 for that.
Yep, so the limit of 1 over cosine squared of x, well, cosine squared of 0 as x approaches 0.
It's just 1.
Yep, it's just 1.
Okay.
So you end up with -7 times 1.
Okay.
All right. So any other questions on that one?
What about the bottom denominator for that one?
For which one? This one?
Yeah,
Oh, this just became 1 because once you plug in 0,
no, the,
You
Oh.
meant the,
yeah.
this
the-
one?
the-
or this one?
Yeah, that one right there.
Oh, here, as you get closer and closer to 0, you can't. That just, let's say if you have 0.1 squared, 0.01, 0.001, it's just smaller and smaller and smaller and smaller.
so it's considered 0.
Yep, so if you divide -7, and as that denominator gets smaller and smaller, it just keeps growing and growing. But the fact that it's negative means that it's going to keep growing and
that's
growing, but then it becomes negative. So whatever number you have that's getting bigger and bigger, you're now multiplying it by -7.
Because, okay, right, because we're approaching 0 from the right,
Mm-hmm.
but I'm kind of confused how that number is technically getting smaller and smaller and smaller.
Oh, because if you have, let's say instead of -7, you just brought that out to the front, and you made that -1 times 7 over there.
Right.
So here, you're technically, let's say if you just have this, then this number is just going to keep getting bigger and bigger and bigger. So if you have just a really big number, let's say you have a trillion. If you have a trillion, if you multiply by -1, it's going to be -1 trillion.
Right.
So if you have -1 trillion squared, if you multiply by -1, it's just going to be negative of whatever that number is.
Right, okay.
So no matter how big this number becomes, you multiply by -1, it's automatically negative.
Right,
Yeah.
I get that, it's just like, hold on.
He's thinking you probably plug in a 0 just like how you would plug in for the top.
Yep.
And then-
That's exactly what I'm thinking.
Then you would get 0 squared, 0, and then multiply the secant squared of 0 plus 2.
Tangent.
Which you can't do that down there. You can't just plug in 0.
Yep, you wouldn't be able to just plug it in.
So how would you know if that would equal either a positive number or a decimal number?
Oh, for which? For this
The
one?
denominator.
Oh, for this denominator here?
Mhm.
Oh, just by that value getting smaller and smaller. So we know that already as this gets smaller, we know that tangent x, as it gets smaller and smaller, just gets closer and closer to 0. So you just have really small number times a really small number times 1, you might as well say, times a really small number, and it's just
Just
keep
think-
getting smaller and smaller and
Just
smaller.
think of it as like that ends up being infinity anyways.
Right,
So if
okay.
you have a -7 over infinity, you just have negative infinity. So,
Yeah, that makes sense.
All right. Any other questions on this one? I don't think I'm gonna have time for. I'm trying to think. I don't think I have time for the last example. we'll run over. But I'll include it in the notes. It's for when you have 0 to the power of 0. So it's just an example for that one.
What's the law of that?
Not really long. It's just one of those where you have to apply natural log to both sides.
Take a picture of it?
Oh, sure. And your exams are up here. You can get a chance. These are exam 1s. If everybody can pick them up. Oh, just wait. Yep.
Oh, sorry.
Oh, there you go. That's great. For everyone.
It's still recording, by the way.
Oh, thank you.